Hello, class, and welcome to our next lesson. Today, I'm going to be talking about diffraction and interference of waves. Now, diffraction is the definition of that is it's the bending of a wave around obstacles placed in its path. And diffraction is possibly most easily depicted once again through simulation. But if we were doing this in real life, we could use a ripple tank to show this, make this apparent to us also. For now, we'll use the simulation to help us visualize it. So here I have a wave generator and I have a slit here, pretty narrow. I'm going to generate a planar wave. The wavefront is going to be a straight line and it's going to approach this slit here in the medium, and on both sides the water is of equal depth. So watch what happens when I go ahead and let her rip. Well, as it crosses this obstacle here, we notice that the waves emanate in a circular fashion. I'm going to go ahead and pause it for a second and take some measurements. Here in this light blue section, we have what's known as a crest. So I'm going to take a measurement here, measure from crest to crest. It's about 2.6 centimeters. Well, wouldn't you know it if I did that here um, in the circular wave part also, it's from crest to crest, it's also 2.6 centimeters. That makes sense though. The frequency is maintained throughout, and the water on both sides of this boundary, on both sides of the slit, is at the same depth. So the water continues to travel at the same speed no matter what. That is this pattern here, this circular pattern is known as single slit diffraction. Now there's a couple other patterns I want to show us. So here, this will be, let me do this one first. Let's watch a planar wave as it crosses a corner of a wall, just as an example. I'm going to go ahead and play it. And again, we see a circular pattern around the obstacle. Now, the obstacle itself, or the diffraction around the obstacle, it ends up interfering with the planar wave on the other side of the obstacle, albeit slightly. So we don't see too much of an interference pattern on this side. However, one still exists. Um, this is more of a unique case. Your book actually gives us this second case a little bit more clearly in some of the pictures, but we're going to see a simulation of it here now. This is known as a double slit diffraction pattern. Again, a planar wave is going to cross through these two slits here, and something really unique happens. Let's watch. We get a circular pattern emanating from one slit. We get a circular pattern emanating from the second slit. Here in the middle, we have a pretty clear nodal line. We see that the crests continue being pretty strong here in the center of the two slits. And then we get a series of, you could call this destructive interference occurring, where the amplitude almost entirely goes away. Let's see the three-dimensional view real quick. Look, amplitude here, 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 and here is very weak, not very strong at all. But here in the center, and also at certain measurements at angles between the two slits, we get pretty strong amplitudes. Um, what does this mean? Well, constructive interference occurs when the crests of one diffracted wave intersects with the crests of the other diffracted wave. And really, this is um, it's a pretty complex interaction. But what you want to know is you're always going to get this strong amplitude, this center in the middle of the two slits. And here on the sides, it just depends. Anyway, that's all for now. Until next time.